Okay, in this problem we have a second order linear recurrence relation, but this time it is non-homogeneous, because if I were to write this as a sub n minus 2, a sub n minus 1, minus 3, a sub n minus 2, getting all the terms of the sequence on one side, the right-hand side is not equal to 0. It is linear in terms of the index n. So this is a this is a non-homogeneous recurrence relation. And so the way that we solve this, we first solve the homogeneous equation. So the first step, let's figure out the solution of the homogeneous equation, where I just simply replace the right-hand side by 0 and see what we get. So we find the characteristic equation is going to be r squared minus 2r minus 3 equals 0. And so solving, we get r minus 3, r plus 1 equals 0, so that r is equal to 3 or r is equal to negative 1. And so from this we conclude that the general solution for the homogeneous equation has the form c sub 1 times 3 to the n plus c sub 2 times negative 1 to the n. Okay, so that's our first step to get the solution of the homogeneous equation. Next, we need to find a particular solution, so one solution, to the non-homogeneous case. So let me write the recurrence relation again, just changing letters from A to P. And we need to find one thing that works. Now, our rule of thumb is to try out something that's linear. Okay, so the right-hand side here is linear. Also, in this case, we don't have to worry about adjusting this because of the rules. And so we can just simply try p sub n is equal to a sub n plus b. And let's see if it works. Where a and b are unknown constants that we need to solve for. So plugging in, we get a sub n plus b minus 2 times a times n minus 1 plus b minus 3 times a times n minus 2 plus b, and that's equal to 8n. And again, I must somehow solve for a and b to make this work. Okay, now this is just going to be a bunch of algebra, so let's just do it and see what happens. We get an plus b minus 2 times a times n minus a plus b minus 3 times a times n minus 2 times a plus b equals 8n. A times n plus b minus 2 times a times n plus 2a minus 2b minus 3 times a times n plus 6a minus 3b equals 8n. Okay, so let's get everything involving n together and then everything that does not have an n together. On the right-hand side, I have n times a minus 2a, that's this term, then minus 3a. Everything that doesn't have an n, I've got b plus 2a minus 2b plus 6a minus 3b equals 8n. And so simplifying, we get minus 4an plus, over here we have 2 plus 6, 8a. Then I have minus 5b plus b makes minus 4b equals 8n plus 0. Okay, so to solve for a and b, I will match the parts. So this is supposed to be true for every value of n. That means that this part has to equal 8, and the thing in brackets has to equal 0. So that gives me a system of 2 equations and 2 unknowns. Negative 4a is equal to 8, and 8a minus 4b equals 0. And so we can clearly solve this. The top equation means that a is equal to negative 2, And then plugging into here, we get that a times negative a is negative 16 minus 4b equals 0, so that b is equal to negative 4. And so there's my a, there's my b. Plugging back into my original particular solution, we find that the particular solution is equal to negative 2n minus 4. And that is one solution of the non-homogeneous equation. Let me remark in passing that when setting this up, it's important that we have, if this is linear, then we have a general linear expression, and we don't just simply write a times n here. It's important that we have the two terms an plus b. I would have gotten in trouble down here at the bottom of this solution if I did not have that constant term there. So all this to say, even though this has one term in it, this is linear, and so we should write a general linear expression. Otherwise, I would have gotten in trouble when I come down here at the bottom. Okay, so up here we found our homogeneous solution. Down here we found our particular solution, and so I will combine those in order to find the general solution. So our general solution is going to be a sub n is equal to c sub 1 times 3 to the n plus c sub 2 times negative 1 to the n. That's our homogeneous solution. Then I add the particular solution, negative 2n minus 4. And that is going to be our general solution for this linear recurrence relation. Now we have one thing left to do, which is to solve for the two constants c1 and c2. And I emphasize that we solve for c1 and c2 after we've solved the homogeneous, after we find the particular and add them together. So I do not solve for c1 and c2 way up here. So what I did not do was to try to solve for c1 and c2 when I found the homogeneous solution. When I found the homogeneous solution, I left it like this, and I did not plug in yet the 0 and the 1 to solve for these two things. But now that I've got the general solution, I will now plug in my 0 and 1 to solve for the c1 and c2. So plugging in 0, this is given to be equal to 0. That's given. And plugging in 0, I get c sub 1 plus c sub 2 minus 0 minus 4. That's my first equation. And my second equation, if I plug in 1, that's given to be equal to negative 18. Plugging in 1, I get 3c sub 1 minus c sub 2. Then plugging in 1, I get minus 2 minus 4. So there are my two equations in two unknowns. And so I must solve for these two equations. So the first equation becomes 4 equals c1 plus c2. The second equation becomes 3c1 minus c2 equals, let's see, so that's minus 18. I get minus 6 over here, so bring that over to the other side, I get negative 12. Now I can solve this by any technique that I wish. In this case, the easiest thing to do is just simply to add the two equations together, so that negative 8 is equal to 4c1, and by adding, the c2's cancel. And so that means that c sub 1 is equal to negative 2. Then I'll plug into either equation. I'll plug into the top. We find that 4 is equal to negative 2 plus c sub 2. And that means c sub 2 is equal to 6. And so finally I can plug back into my general solution to find the solution for this particular linear recurrence relation. So a sub n is equal to negative 2 times 3 to the n plus 6 times negative 1 to the n minus 2n minus 4. And there is my general solution, my closed form solution for this linear recurrence relation.